Welcome to this Talks at Google event in our Seattle office. I have to admit that since I was a little girl, I've been fascinated by space and stars and planets and the universe. And so it gives me a great pleasure to introduce today's speaker. Dava Sobel is a former New York Times science reporter and a repeated New York Times best-selling author. Her previous books include Longitude, about the English clockmaker John Harrison, and Galileo's Daughter, about Galileo's older daughter, Maria Celeste, and Planets, which I'm sure you can guess is about Earth and her nearest neighbors. She's a recipient of the National Science Board's Individual Public Service Award, the Boston Museum of Science Bradford Washburn Award, and she even has an asteroid named after her. Please let's welcome Dava Sobel.
Thank you. Thank you very much. Okay.
Thank you.
So I'm going to talk today about a group of women who worked at the Harvard Observatory starting in the 1880s. And the women in this picture don't have a whole lot to do with that story. They're kind of the granddaughters of the original group. But the woman whose picture is over the word glass, that is Wendy Friedman, who was head of the Carnegie Observatories in Pasadena for years. Now she's at the University of Chicago. And she gave me the idea for this book. About 20 years ago, she was the head of a Hubble telescope key project about the expansion rate of the universe. And she mentioned the name Henrietta Leavitt to me. And I had never heard of Henrietta Leavitt. And then when I went to learn more about her, it turned out she was working in a whole room full of women at Harvard. And that was surprising. Any large number of women anywhere at Harvard. But the Harvard Observatory, where they worked, was really separate from the university. And there had always been women working there because several of the astronomers just lived at the observatory. So their wives, sisters, daughters got roped into doing whatever needed to be done. And there was a lot of computing work. So this was an era when computer was a job description. And a lot of what they were looking at were stellar positions. That's mostly what astronomy was about in the 19th century, mapping the stars, figuring out positions, and then the computers would have to make corrections for the atmospheric distortion, for the Earth's motion in space, precession. So there was a lot of computing to do. And then in 1877, a very young physicist, Edward Pickering, he was 29 years old, took over as director of the observatory. And there was a lot of question about whether he was the right person for this because he was a physicist, not an astronomer. And he immediately got interested in doing projects that would uncover the physics of the stars. He wasn't as interested in just the position work. He had to do that, but he introduced other things as well. And he'd been teaching at MIT, where he set up a laboratory so the physics students could learn things for themselves through experiments that he set up for them. And this is what the building looked like in the early days. It was a wooden building, and there were two telescopes, and then the director's residence was the part without the dome. And one of Pickering's first projects was to try to determine the different brightnesses of the various stars. So this was the main instrument at the observatory. This was a 15-inch telescope that was a gift from the people of Boston. And there's Pickering in the chair. I mean, I don't know if it's really him, but somebody is sitting there. So to do this work, the brightness work, he had to build his own photometers. And at first he attached them to this instrument, but later later they got more complex and had their own telescopes attached to them. And he was very interested in photography. His younger brother was a photography pioneer, was also at MIT. And this man, this is Dr. Henry Draper, who was a medical doctor, but was a real pioneer in stellar photography. And not just taking pictures of starscapes, but using prisms to split the starlight into spectra and then photographing the spectra. And he was the only person who was able to do that at the time. And the lady there is his wife, and they worked together. She became his full-time assistant, and because he was an amateur, he was free to do this unusual new work that was not being done at other observatories. And because she was independently wealthy, he could afford to build instruments, take whatever time he needed. And they were planning to leave New York City. They had a townhouse in New York City, but they had an observatory up the Hudson River, and they were going to go devote themselves full-time to this project of photographing stellar spectra and then figuring out a classification system for the stars based on differences in the spectra. And they had all their affairs in order to do this, and then he suddenly died. He was 45. And she really wanted to continue the work. She thought she might get some assistance to fill in her husband's knowledge and work with her, but it turned out to be difficult, and so she offered Pickering the money to do the work, if he would just take over this dream project. And she wanted him to promise that he would name it after her husband. So it became the Henry Draper Memorial. And so this is a textbook image of a spectrum. It's what people usually think of, the rainbow and the absorption lines. But of course there was no color photography yet. So the images looked like this. The enlarged images looked like this. Pickering's photographs looked like this, mostly, because instead of putting the spectroscope at the eyepiece, he was putting the prism over the light gathering end of the telescope. So he was getting hundreds of spectra in each image. And so the job was to look at those tiny smears through a magnifying glass and then come up with a system for classifying the stars. The black spot is a penny. And so with all this money, Mrs. Draper's money was the equal of the entire operating budget of the observatory. So Pickering was free to hire more women. He had found women working there when he arrived, and they were good at what they did, and they were less expensive than men. It's an old story. It's still true in a lot of places. This is what the computing room looked like. This woman, Williamina Fleming, had come to the observatory to work as a maid. She found herself suddenly unmarried and pregnant, and just applied for this job. And then Pickering noticed how intelligent she was and moved her into the observatory, where she learned how to do computations and also how to look at photographs. And she went home to have her baby, but he promised her home to Scotland. She was a Scottish immigrant. And he promised her a real job if she would come back. And she did. And she made the first Henry Draper classification of 10,000 stars, which was published, and she was credited for it. And then she became the first woman to have a university title at Harvard. She was the curator of astronomical photographs. She also managed to bring the baby over and put him through school at MIT, and he became a mining engineer. The very formidable looking woman at the telescope here is Maria Mitchell, who was the first American woman who really became famous as an astronomer because she discovered a comet in 1847. And the young woman, Antonia Mori, was Henry Draper's niece. And she went to Vassar College, where Maria Mitchell was professor of astronomy. So when Antonia Mori came to work at Harvard on this project, she had a very good background in astronomy. And she developed her own stellar classification system, which was much more complicated than Mrs. Fleming's. So for a while there were two systems. And it took a third person to balance out that situation and create something in the middle that was so effective that it's still in use today. And this is Annie Jump Cannon. She was a graduate of Wellesley College. So these new women's colleges became feeder schools to the project at Harvard. And there was a lot of controversy at the time whether higher education was good for women. There was even a feeling that college was actually bad for girls and that it would negatively affect their ability to bear children. I couldn't make that up. But Pickering was all for it. And not only was he hiring women, but he was appealing directly to the alumni of these colleges and saying, you know, if you've studied astronomy, if you have a telescope, there are observations we need to have made, and you could contribute to the work. And he got a lot of takers for that. Miss Cannon was the first woman at the observatory who was not just looking at photographic plates, but making her own observations. So the painting of her at the telescope is from a children's book called Annie Jump Cannon Astronomer by Carol Gerber, and the illustrations are by Christina Wald. So here's one of Miss Cannon's plates. It's not for everyone. And these are Miss Cannon's diaries. One of my concerns when I took on this project was, would I be able to make the women come real in the story? Or were they just going to sound like one lady nerd after another? And fortunately, the archival material was rich. And 40 years of Miss Cannon's diaries, I probably know her better than I know some of my friends. And this is thrilling kind of work to do. I don't know if any of you have ever had this experience of going to an archive, but it's just, it always surprises me how much is available just by virtue of being interested in a subject. You know, this is just there for the asking. So in order for Pickering to create a complete record of the night sky, which was what he wanted to do, he had to have an observatory in the southern hemisphere as well as the northern hemisphere. And he sent this man, Solon Bailey, to reconnoiter sites in South America where they could carry on the work too. And this was their first spot. They called this Mount Harvard, very rustic. And then they built a more permanent installation near the town of Arequipa in Peru, in the lee of a dormant volcano, El Misti. And later it turned out it wasn't so dormant, but they were there. And for the southern hemisphere, Pickering wanted a new kind of telescope, which he designed specifically for photography, and one that would take enormous plates. These were 11 inches by 17 inches. And once again, an interested heiress stepped forward, wrote him a check for $50,000 to build this telescope, which has her name. Her name was Catherine Wolfe Bruce. And she also endowed astronomers everywhere. She set up a grant pool, and if you had a proposal, you could send it to her, and Pickering would do all the judging, and she'd send you some money. And she was also approached by the Astronomical Society of the Pacific to endow a Lifetime Achievement Award for astronomers, and it remains a very prestigious prize today, the Bruce Medal. So life in Peru wasn't all fighting scorpions and staying up all night. They had picnics sometimes, and this lady, I'm not getting this to work. There she is. That's Mrs. Bailey, Ruth Poulter Bailey, and she helped him in the work. She did the meteorology observations, and she also helped in his studies. He was especially interested in globular clusters. The dark skies in South America really made these pop, and he was fascinated to see how many variable stars there were in these clusters. So even with the close-up, you can imagine the job it was to count the stars in these images. But when you got to the middle, it was really mission impossible. Henrietta Leavitt, the first name I learned of these women, she was given plates from the Bruce telescope to discover as many variable stars as possible. And so that meant not only looking at the images, but then looking at them over time. So you assess the brightness in one image, but then you keep assessing it as you look at subsequent photographs. And this is the Small Magellanic Cloud, which is not visible at all from the northern hemisphere. And so she was finding about 1,000 variables in this one object. And it struck her that all of the stars in the Small Magellanic Cloud were roughly the same distance from the Earth. So that if stars looked brighter, then they really were brighter. And among the variables, she made this very important discovery that the brightest ones took the longest time to cycle through their changes. And so that meant if you saw one of those stars in another part of the sky, and it had the same period as one of these, but it looked a lot dimmer, then it was a lot farther away. And that was the beginning of a distance scale for measuring the universe. And that, too, is still in use today. And there's a movement afoot, a successful movement, to change its name from the period luminosity relation to the Leavitt law. Harlow Shapley took over as director of the observatory after Pickering died, and he used Miss Leavitt's stars to determine the size of the Milky Way, which was so gigantic that he assumed that there were no other galaxies. This was a big debate at the time. Was the Milky Way the only one, or was the Milky Way one of many island universes? And he felt, when he realized the extent of it, that it was the only one. And he also figured out from judging the distance to all the globular clusters he could see that the sun and planets were nowhere near the center of the Milky Way. And he just took a perverse delight in that, in kind of showing how unimportant we were. And he said that man is not such a big chicken. We're really peripheral to the universe. Shapley was also very interested in ants. He noticed them while he was working at Mount Wilson, and he studied them scientifically. He wrote several papers that were published about ant behavior. So I wish he could have seen this cartoon. This is a Charlie Hankin cartoon from the New Yorker. And since the caption doesn't show, we could pretend it's one of those contests that they do now. But we don't have a lot of time, so I'll just tell you what it says. Kind of makes you feel small, doesn't it? Shapley argued that what Harvard really needed was a program in graduate level astronomy. And he wanted to institute it. And he said, if they'd had one, they wouldn't have had to import him from California. They could have promoted from within the ranks. And because of the history of women at the observatory, there was a third heiress, Lydia Hinchman, who was a relative of Maria Mitchell, and who set up a program to pay for a young woman to come and work at the observatory for a year and then go on to have a job somewhere else. And so when Shapley started looking for graduate students, the only fellowship support he had were these fellowships for women. So he recruited from the women's colleges, and all the early graduate students were women. And the smallest photo, this lady, is Cecilia Payne, later Cecilia Payne Gaposchkin. And she came to Harvard from Cambridge, England, and partly she was attracted by the ability to think about a future in astronomy in America, which she knew was going to be impossible in England, but also the plate collection, that she wanted to use the plates of the spectra for her own research. And she was the first person to earn a PhD in astronomy at Harvard. And in the course of her doctoral research, she showed that the different categories that had been set up by the spectra, that what they really signified was stellar temperature. And then she was looking at the spectra to assess the relative abundance of different chemicals. And she came up with strikingly high percentages of hydrogen. And it just looked very odd. It was not what anyone expected. So her advisor, Shapley, and the reigning authority on stellar composition told her not to make too much of this, just say, okay, these were my findings, but it's probably a spurious result. And that's what she said in her dissertation. But she had called attention to this interesting problem. And that got other people looking at it. And it took only 4 years for everyone to agree, it really is almost all hydrogen and helium. So that was her finding. So when some people have heard about these women, you often hear them referred to by the derogatory term Pickering's harem. But I want to stress they really were well treated, well regarded. He put them up for prizes. They were members of the American Astronomical Society. They were even inducted as foreign members of foreign astronomical societies. And they loved the work they did. Nobody left. People worked there for 30, 40, 50 years. And then they've really, some of them achieved world fame, especially Miss Cannon. And shortly after she died, she was featured in Wonder Woman comic book as a real-life Wonder Woman. That's what this is. Now she's in a current website called Rejected Princesses. And this is all about women who are too awesome, awful, or offbeat to be featured in a kid's movie. This is a still from the remade Cosmos. Did anybody see the original Cosmos series with Carl Sagan? So he was a tremendous influence on me. And the original writers did the new series and just used Neil Tyson as the host. But the new series contained something the original didn't, which was an episode about the Harvard women called Sisters of the Sun. And so there's Annie Cannon at the light table, and that's Henrietta Leavitt standing at the back. And this has had a huge effect. There are young people who've seen this now, and there are 2 new plays that have been written about the ladies. And there's a web series in production about them called Insignificant, which looks like it's going to be really good. They've even made it to Legoland, and you could have a t-shirt with this image on it. So that's Miss Leavitt with the magnifying glass, and Miss Cannon with her stellar classification, and Dr. Payne with her primary constituents of the stars. This is a work by a young artist from LA. Her name is Leah Halloran, and she has been looking at the glass plates. There are 500,000 glass plates at Harvard, so that's really the glass universe, and they cover a complete century. Northern hemisphere, southern hemisphere, chart plates, spectral plates. And so she sees them as artworks, and she's reproducing some of them as works of art. And these are enormous pieces. They're about 6 feet square. And they're going to be in an exhibition next spring called Your Body is a Space That Sees. And there's still lots to be done at Harvard. So there's a digitization project going on now for the plates that's funded by the National Science Foundation, because the full information content has never been mined from these plates. And from the beginning, when they began accumulating in the observatory, people would come to Harvard just to be able to use them. And sometimes Pickering would actually send the plates out to people if he thought they were serious about their work, and they took that risk. So when they're digitized, it'll be a lot easier for everybody to look at them, and you won't have to worry about breaking the fragile plates. I don't know how many of you know there was a flood this year at Harvard in the place. That lovely wooden building, the minute the plates started accumulating, Pickering started agitating for a brick building, fireproof brick building, which he got. And that's where they are today. They're still in the building that was specifically built for them. But nobody counted on a broken water main. And about 60,000 of the plates got submerged in muddy water, but along with the digitization equipment. But everything has been rebuilt, and they're going again. And there's also opportunity for people who want to help digitize all the logbooks. So there's a Smithsonian crowdsourcing platform. People are doing it. So here they are. Just about everybody's in this picture, everybody I've mentioned, except for Miss Leavitt. She had died by this time. But just seems to me, in the light of recent events and the anti-science bias that maybe you don't feel here at Google, but it's out there and it's really terrifying. So I feel it behooves all of us to tell true stories about science, and maybe especially about women in science, because there aren't that many examples for young women. And this group was pretty terrific.
So, as is my prerogative, I will steal the first question.
Okay.
And my question is, this is 100 years ago. We have much bigger telescopes now. We have much more people working in astronomy. Are these plates still being used for current research, or is it more historic research?
It is current. They call it time domain astronomy. So things that are discovered now, you can access a plate of that exact part of the sky and look to see what was there then. And that has proven instructive in many cases.
So from what you said, it sounds like there was a few things that went into making it possible to have this, close to gender equality at this moment in time, right? There was the economic force of them being cheaper to hire. There was the grants that were available just to get a woman at that point in time. And maybe even just they didn't have opportunities elsewhere to find other work for, very intelligent women at that time. And a lot of that started to change, around like 1940s or so, right? So real computers came in, or electronic ones, and other jobs for women started to become available. So do you know if this was there like an upward or downward trend? Was this a moment in time, or was astronomy still an interesting area for women after that?
Was astronomy still an interesting area for women?
Or an area of equality, I guess.
Well, not everybody considers their opportunity an equal opportunity at that time because they were paid less, but it still was a sensational opportunity. And the fact that they worked at Harvard and that people knew about it made it possible for women to go and work at other observatories where they were allowed to make observations and have opportunities I don't think they would have had without that situation. So one of the other things that went into it was Pickering's open-mindedness and willingness to entrust that kind of judgment work to the women who worked for him. There are, I think astronomy is a field where women have a lot of opportunities, maybe not as many as they would like, but it's pretty good. And at Harvard now, about half the astronomy graduate students are women.
So you mentioned you had gotten the original spark for this book about 20 years ago. Can you tell us about the process of how you got into actually going after these archives and developing this project?
Oh, sure. Oh, yeah, that's, well, it was at the back of my mind, but I had other things that I worked on for a long time. I always wondered, would it be possible to even write this book because there were so many characters. I've mentioned that. And so I worried about it. But then the more I learned about them, in the early 90s, there was a special issue of Mercury, the magazine of the Astronomical Society of the Pacific, that was just devoted to women in astronomy and told some of their stories. And I thought, this is just terrific. I can't believe nobody's done this. And then there was a book just about Henrietta Leavitt called Miss Leavitt's Stars by George Johnson. And I always felt kind of bad for him because she was the silent woman of the group. She didn't write letters, she didn't keep a diary. If you're gonna pick a person to write a biography, she was just the toughest one. Her discovery, her work was probably the most important thing, but he was really stretching. He wound up giving what her grades had been at Radcliffe. And I didn't want to be in that position. But finally I convinced myself the story was so good that I would just have to count on being able to find the material. So I first started at the plate stacks. So that's what they call the huge library of 500,000 plates. And just looking at them was so exciting. The way they're written on, so there's always something in a project that makes me understand what really went on. And the curator will give you one of those little magnifying loupes, and you can lean over a light table and look into one of those plates and see the depth of it. And then I was really hooked. And then I learned about the diaries, and I had confidence that I would be able to do it. So it meant a lot of being at Harvard, because the archive is open only 5 days a week, and only 5 hours on those 5 days. So I'd be there just before they open, and then I didn't even go to the bathroom. I mean, it was just, because the wealth of material, I mean, not just the diaries, but the observatory correspondence, everything was documented from the 1870s. They made a letterpress copy of every letter, whether they were designing a new telescope, ordering new ink, whatever they were doing, it was documented. So it was just so much stuff to go through. And then I had to realize that I wasn't going to get through it all. So that was difficult, to just pick, okay, I'll read these years of the diaries, I'll read this person's correspondence. And then fortunately, I had a visiting professor, writer-in-residence kind of position at Smith College. And so then I was nearby. And that made it possible too. And what else was it like? There was a lot of science that happened, because at the beginning of the story, nobody knew the constitution of the stars. Nobody knew what made them shine, how far away they were. It was really, I mean, the only thing that was known was position. So, and by the end of the story, almost everything was known, at least in outline. So there was a lot to cover, and I had to learn a lot of astronomy. I mean, this has been the thing I've written most about, but it was a stretch, and I had many days of saying, whatever made me think I could do this. But I'm really pleased with the way it came out. Did you have a question?
Yeah.
Oh, I'm sorry. Did we know?
I just wanted to ask, were there people around to help who knew something of the story?
There are very few people left who knew the real people, but there are a couple. Some of Cecilia Payne's graduate students are still alive. And then, if you're interested, the American Institute of Physics does an interview series. And so she's one of the people who's been interviewed for that series. And there's even a little clip you can hear her voice.
When did this period end?
So the big money infusion started in 1886. And then, so the women were there. And it went through World War II. During World War II, they all did war work. Mrs. Shapley was working for the Navy, doing ballistics trajectories. There was a lot of ballistics trajectory work. And then by the end of the war, there were the machine computers coming in. And the observatory had less money. But they kept it going till the 1950s, when Miss Payne, Dr. Payne, became the first woman promoted to a tenured professorship at Harvard. And yeah, I guess that was your question. Yeah, through the early 1950s.
Huge fan, thank you for coming.
Oh, thank you.
I used to teach with Longitude, and I had to walk my students through localization, yada yada, and then ending up ultimately with the solution as a clock, obviously. And I'm always impressed with your ability to take technology and history and put it in, we're living on this unbroken chain of technological innovation and getting context on that. But the highlight of that was going to Greenwich and seeing the clocks. So that kind of historical tourism was really remarkable.
Good for you. Great, I'm glad you got to do that.
Is there an analogy
for this story?
For this? Yeah, is there a place
we could
to
go to
see?
Harvard and see the plates.
It's just that simple.
Yeah. Now at Arequipa, that place has been decommissioned, and the building that housed the Bruce telescope is a chapel. And I'm kind of curious to see that. I don't know if I'll get there. They also had a station in South America, which is no longer I mean, it's no longer Harvard. It's still an astronomy station. But yeah, you don't have to go that far. You could just go to Cambridge, Massachusetts.
The last question is, what's next?
I don't have a next idea, and I feel I'm not really finished with this story. I've never seen a life documented the way Miss Cannon is documented. I mean, aside from the diaries, there's every libretto from every opera and she was a big opera fan. She was deaf, but she had enough hearing that she loved music. And so, as I said, I didn't get to read everything, and I'm kind of still in this story, and I'm also struck by how few people know about it. So I put together a committee of about 10 people who agreed to read the manuscript as technical experts because I didn't trust myself that I'd really gotten all the facts straight. So one of them is a woman who's a full professor of astronomy at Harvard now. And she, of course, had heard about this situation. But she immediately got distracted from her job as a technical reader. And she said, I didn't realize they were doing real science. I always thought it was something just cute or quaint. You know, this is a completely different situation. And Miss Cannon she won many honorary degrees and awards, and she took one of her awards and endowed a prize for a young woman astronomer. And this faculty member had been put up for that prize. And she said, I don't want it. I don't want any prize that's just for a woman. So now, knowing the history, she had a different feeling about it. So I think this is too important a story to, I mean, so many stories get forgotten. I mean, how can we remember everybody in history? But this is a really good story. And somebody else came up to me recently who was a woman, a 1981 Harvard graduate, who was one of the first in the women's studies program. Never heard of these women. So I don't know. I think I want to go be an advisor or a kibitzer to the people who are doing the new plays and the web series. I think that'd be fun.
I wanted to go back to Longitude, if you don't mind.
I don't mind.
The first one. It was the first one of your books that I read. I had the illustrated version, and I'll never forget flipping through the plates in the middle, where there's a picture of John Harrison's first chronometer, which looks like a space alien contraption, and then you flip the page, and there's 2 and 3, which also look like space alien contraptions, and then you flip the page again, and there's 4, which suddenly looks like a modern clock.
Yeah.
A question I came away from the book was, what happened to John Harrison in between 3 and 4 that let him suddenly come out with something that looked like, it looked like something that might be up there for us today?
Well, it wasn't sudden, if you remember. It took about 20 years, that book.
Oh, yeah, 20 years.
Yeah.
So that was one thing.
So it wasn't sudden. And a couple of important things. He got somebody to make him a pocket watch just for his personal use, and was able to put in one of his innovations, the temperature compensation. And that convinced him that it would be possible to build something small. He'd been making these very large instruments because large seemed synonymous with accurate. And when he realized that it was possible to make it accurate and small, then he was willing to sacrifice some of the other parts and went back to an old-fashioned escapement and put the whole thing in a small package.
So in the course of your work on this book, what were some of the things that most surprised or delighted you?
I think most surprising was the graduate education situation. I hadn't realized that. And even when I was at least a year, maybe 2 years into the project before I thought, all the graduate students are women. So that was interesting. Then I had one of those weird moments. Priscilla Fairfield, who was a Smith professor and got involved in the Harvard work, she would go there. She would spend the whole summer working at Harvard. So she was constantly corresponding with Shapley about their projects together and what was the next thing to do. And she always wrote to him on Smith College Observatory stationery. And one day she wrote to him while she was working at home, and she put her home address, and it was the building I was living in at Smith College. It wasn't on the college campus, it was just in the town. And so that was a big surprise. What else? Just the acceptance of them. Because I had heard the term Pickering's harem, and I had heard all the flap about how little they were paid. So I wasn't expecting the kind of recognition that they got. You know, especially the foreign, the Royal Astronomical Society. You know, both Mrs. Fleming and Miss Cannon were foreign members. That was remarkable. And then the collegial nature of astronomy. I think it has always been an international science because you have to have people all over the place to get hold of it. But Harvard really became a hub, and people would come from Europe and work there for weeks, months at a time. And then they were all corresponding with each other. And even during World War I, Pickering was so reluctant to break off relations with anybody in astronomy. And immediately at the end of the war, you know, he couldn't wait to get in touch with the German observers and how were they doing and what had happened to their observatories and how astronomers should really rally and all cooperate again. So those were all kinds of feel-good things. It's a happy story for the most part.
Any other questions? Anybody? All right, so with that, thank you very much.
Thank you.